Okay, here next we will learn about linear equation. Okay, linear equation, you can solve a linear equation using a matrix. Okay, for example, you have an equation of three equation, which is a11 times x1, a12 times x2 plus x3 x4. So you get the first equation, then you have second equation, and you have third equation. These three equation can be written, okay, in terms of matrix. Means the numbers will be on your left side in terms of matrix, then your unknown will be on the second row and equal to your right hand side, be a third row. So we call it as matrix times x. Okay, matrix times x is equal to small b. So where is your A is a matrix of coefficient, your x is a vector of unknown, your b is the right hand side solution. Okay, so this concept is valid if b, okay, your b is equal to 0. Okay, if your b is equal to 0, okay, this is valid when your b is equal to 0. The equation are called homogeneous. Meanwhile, if your b is non-zero, okay, this one is not a 0, then we call it non-homogeneous or inhomogeneous. Okay, in this case, we have a fourth case related with the solution. Okay, we go one by one, which is case number 1. Okay, if your b, okay, if your b is not 0, okay, this is not 0, there is a value, but your determinant is not 0, so we know with determinant not 0, the inverse is exists. So we can say that inverse A times A is equal inverse A times B, so that we can say x equal to inverse B. So you want to find the x, you just inverse your matrix, okay, inverse the matrix times the B, so you get the value of x. This is the common case number 1, so you have direct solution. Okay, we go for case number 2. The rule is when b is equal to 0, okay, but your determinant is not 0, so automatically we know that there is a exist of inverse A, and the homogeneous equation become A times x is equal to 0, A inverse times A x equal to A inverse times 0, means your x is 0, so the value will be always 0 due to the b is 0, and also there is a inverse. Okay, then we go for case number 3. Okay, okay, for case number 3, when your b is not 0, okay, you have Ex equal to b. When your b is not 0 and your determinant of A is 0, so automatically we know there is no inverse doesn't exist due to this one. So it's perhaps more complicated, so we have two possibility, which is either we have no solution or we have infinite many solution. Okay, for example, you have 3x times 2x equal to 2, the first equation, and we have the second equation of 3x plus 2y equal to 6. Or in matrix is 3 times 3, 2, 3, 2, 2 times 2 matrix, x and y, and this is your a, this is your x, this is your small b. So this is clearly that your x and y is not exist due to the 0. 3 times 2 is 6 minus 3 times 2 6, so you cannot answer this left hand side. But in this case, okay, we are clearly inconsistent and no solution exists. Okay, that's the first one. There is no solution exists. Okay, for the second one, you have 3 times 3x plus 2y, 6x plus 4y equal to 2 and 4, or 3, 2, 6, 4 is equal to xy times xy equal to 2, 4. Here you will notice that on this side your a will be a 0, your x, but your b is 2 times. You felt this is 2, this is 4, so means 2 times. So you can simplify this one, means that, for example, we are taking x is equal to lambda, you are taking one of the equation, 3 lambda plus 2y is equal to 2. So you will get 2y is equal to 2 minus 3 lambda. Okay, then you get y equal 1 minus 3 over 2 lambda. So we can see that y have this amount of value in terms of lambda. So this is valid if the b is to have a times 2 times or 3 times. Okay, so this is case number 3. Okay, the last one is case number 4. What happen if your b is equal to 0, your a determinant also 0, means in this case, as in case we have infinite many solution. For instance, the case of 2 equation takes off, you have ax plus by equal to 0, then you have a lambda equal to 0. So you know that your determinant is equal to 0, and we find solution of x is equal to lambda. Okay, you just take x to lambda, so you get y equal to negative lambda divided by b if b is not 0. If b is 0, then x is automatically 0, y is lambda is the solution. So yes, here we have 4 types of case that related to the linear equation. Okay, so we go for example. Okay, write the 5 sets of equation in matrix form and decide whether they have or do not have a solution. Okay, we go for one by one. Okay, for example, so A you have 2x plus y equal to 5 and x minus 2y equal to negative 5. So here your determinant is, oh sorry, before that we do the matrix first. Okay, your matrix will be 2, okay, 2, 1, 1, negative 2, okay, times x, y equal to 5, negative 5. So this is your matrix. Okay, so means that this is your A, this is your x, and this is your small b. Okay, so next step you need to find the A determinant. So here you will get 2 times negative 2 minus 1 times 1. so you will get negative 5. So technically we know this is not 0. So when your A determinant is not 0, your B is a 0, so this is under case number 1. So you can find the answer, okay, which is, when you do the answer, you will get x equal to 1, y equal to 3. Okay, so how to get the answer is, you get x is equal to A inverse times B. So you need to inverse the A matrix, then you times with your B, you will get the value of x. So the value of x is this. Okay, we go for B. B is, the matrix is 2 1 1 negative 2 x y equal to 0 0. Okay, in this case we need to calculate the determinant of A. So you will get 2 times negative 2 minus 1 times 1, so you get also negative 5, which is not 0. So but your B is equal to 0, so automatically we know this is under case number 2, which has a trivial solution. So you can see that your x is equal to 0 and your y is equal to 0. Okay, we go for question number C. Okay, in matrix form, your C will be negative 3 6 1 negative 2, then your xy, then you will get 15 negative 5. Okay, first of all we need to calculate your determinant of A. So you will get negative 3 times negative 2 minus 6 times 1, so you will get 0. Okay, meanwhile your B, or your right hand side, is not 0, so automatically we know this is under case number 3. So there is a solution are not easy, so we need to do some arrangement. So where is, you can change, okay, so we can change your y equal some number, for example t. So your equation will be, the first equation will be x minus 2y equal to negative 5. Now we change y to t, so you add x minus 2t equal negative 5. Okay, so x is equal to t minus 5. So the solution is based on this answer. Okay, next we go for D. Your D is, in terms of metric, is negative 3 6 1 negative 2, then we have x y, then we have 10 to negative 15. So here we know that your determinant is equal to negative 3 times negative 2 minus 6 times 1, so equal to 0, and your B is not 0, so this is under case number 3. But due to there is no double up of the B of answer, so hence the solution is not easy. because they are inconsistent. No solution to this set of equations, so there is no solution. Okay, then E we have a matrix of -3, 6, 1, -2, then we have x, y, then we have 0, 0. So first of all, you need to check your determinant. Your determinant will be -3 times -2 minus 6 and 1, you will get 0, and your B is also 0. So this is under case number 4, where is no solution, no trivial solution exists. So okay, we go for another example. Okay, the new example. Okay, find the solution of this equation. Okay, so in order to solve this equation, so we change this one to a metric form. So the solution of metric form, we will get 1, 1, 1. You will get 1, 1 and 1, 1, 2, 3. So you get 1, 4, 9. This is your A matrix. Then you have X, Y and Z equal to, what is your B is 6, 14 and 36. Okay, so this is your A, this is your X, this is your small b. So first step, you need to find A determinant. In this case, you will calculate your A determinant is equal to 2. Second step, you need to find A inverse. In this case step, you will have a 3, -5 over 2, 1 over 2, -3, 4, -1, 1, -3 over 2, 1 over 2. This is based on the formula of A inverse equal to 1 over A determinant adjoint A. So you get this one. Then once you have both three, you can answer the question, where is your X is equal to A inverse times B. So you will get your X is equal 1, 2 and 3, means that your X equal to 1, your Y is equal to 2 and your Z is equal to 3. This is your solution. Okay. Okay, I can show you another example. Okay, this is another example. find the value of k for which the equation have a non-trivial solution. So means that it's already stated that there is no solution, trivial solution. So the solution will be okay, this you have a, x and b. So we know that non-trivial solution means your determinant will be equal to 0. This is the key point based on the question. Okay, so automatically you find the determinant, you will get equal to 0. This is your equation. So thus the equation have non-trivial solution. So your k equal 1 if k is not 1. So if k is 1, if k equal 1, the only solution is x, y and z equal to 0. So for k equal 1, a simple calculation given that x plus y is equal to 0, which is you can take x is equal to lambda, y equal to -2 lambda and z equal to 3 lambda. Okay.